stopping by. I wanted to share with you guys my story of what I'm dealing with. My case 15 years ago, I crashed on a bicycle, unfortunately, a mountain bike, and injured my spine. So I've been dealing with it for quite a while. So it's pretty awesome that I work in the world of 3D printing and additive manufacturing, so I can utilize the technologies that we use for my own case. So I printed a whole host of different models, through the years, and it's pretty cool to take those models into when you see a doctor, a neurosurgeon, or whatever, and you actually have models of your anatomy. So going to talk to you guys a little bit about that today, just how we use the technology. A couple of amazing partners that we have in our company, Stratasys and Axial. So we use Stratasys technology platform to actually do the printing, called digital anatomy, and our friends from Axial to do the segmentation, which is done directly from the DICOM data. So digital anatomy printing is one of the key ways that you can actually print models that mimic actual human anatomy, tissue, bony structure. We've been one of the early adopters, partnering up with Stratasys many years ago. So we do this for, orthopedic cases, cardiovascular, neurovascular. We've printed tons, hundreds and hundreds and hundreds of patient-specific models through the years. I don't want to get into all that. I'm going to talk to you guys mostly about my situation and my case and how I use it today. The models that I have here are the most recent models. I've been trying to avoid having to have a surgery for many years, so I've gone in for different procedures and injections and facet injections and things like that, which has worked out really well. The step-by-step process, obviously with our partners with Axial, who my good friend, Mr. Chris Pedro, is here from Axial, so you can talk to him about the platform as well. The way that we do that is from the native DICOM data from an MRI or a CT scan. One of the trickiest things about that is actually doing the segmentation. So through the years, different companies have gotten into that market to do that, and it's somewhat cumbersome. It takes a lot of time. You have to have a whole army of engineers to do this work. Now with the Axial platform, you can literally do segmentation in minutes, which I'm a living example of that with my spine, with my case. So the technology platform is amazing, and what it does is it allows us to scale. One of the issues that we have is we need to make hundreds and hundreds of thousands of these models. All of the data is out there. I'm sure you can talk to many of the companies that are presenting today about the data, how much that having these models transforms and makes surgical outcomes better for the patient, for the insurance companies, the providers, the surgeons. And I'm a living example of that. So we start with segmentation from the DICOM data. We bring that in and create a mesh file with the Axial software. I'm simplifying it. It's a little bit more complicated than that, but we don't have a lot of time. But from there, we get a 3D print ready file. One of the advantages of having that 3D visualization data for the patient, for the surgeon, or the care provider is just having that alone you can do so much with, as opposed to not having that in 3D, spinning, rotating. I have some examples of that with my case, with my spine actually. And from there, we obviously move into creating physical models. There's a whole different host of ways that we do that, but one of the best ways to do it, in my opinion, is with digital anatomy printing, because you're able to recreate the bony structure, you're able to recreate the soft tissue in those models. The way that that's done, I have a video playing behind me that you can see with the polyjet technology. So the nice thing about that is you can jet a whole host of different materials, full color, like I said, flexible, rigids, all in one shot. So at the end, what you get is these. And I'll go ahead and start over here and pass these around so you guys can take a look. Fantastic. So what do we use these models for? Obviously, they use them primarily for the surgeons, right? So pre and post planning for complicated surgeries, different things that they're able to use them. A lot of the models actually go into the operating room with the surgeon, and I have spent a lot of time interviewing, talking to some of the top surgeons around the world that in orthopedics and cardiovascular. The data is there. Part of the issue that we have is that it's not fully adopted yet. Why isn't it fully adopted yet? Well, there's this little thing called billing codes. There's a reimbursement model that needs to happen, right? If you're going to spend the time, to do these types of things, there needs to be a reimbursement model. And at first, The first experience that I had with doing this type of work was back in the early 90s, and with software, it would take us 24 hours or longer to just crunch the data with computing power back then, and printing could literally take 1 to 2 weeks to get a simple model, and now we do that in minutes. We have Axial with the technology platform. We're able to print models overnight. We've saved many people's lives with these models, or extended life with creating these models for different patients around the world, which is really cool. There's nothing better that you can ever work on, than that. And so that's one of the reasons that I've always gravitated toward the medical side, of the business. So, and it's really cool to be able to talk about it when you're actually living it and you're using the technology for your own self. There's no better story to tell than that. So this is one of the ways that we, create models, technology that's been around for a long time. Also stereolithography, which is another option for being able to build models. Digital anatomy printing is not the only thing. There's so many different materials and technologies that we have, but digital anatomy printing is what we're focused on today.
Awesome. I like the much ones.
So here's an example. This is with Axial. This is a picture of my spine after the segmentation was done. You can, if you know a lot about the spine and the anatomy, if you look in this area is where I have, a pretty significant issue. And so I've chosen to try and avoid having to have a larger surgery. So I use the models as my anatomy has changed over the years, and I print these. I'm able to take those in, like I said, to my doctors and also the neurosurgeons. Go, hey, how are we looking? What's my pain level like? How are things changing? Most recently, I had some RF ablation done on the nerves, and using these models and this data was so helpful for my surgeon to be able to use that, and then have the physical representation of the model in hand is something like on the screen. It's great, but there's nothing better than having something that you can hold in your hand like what you have there. So back to digital anatomy printing. Again, I don't know, a show of hands of who knows what that is or has used it before. Does everybody know what digital anatomy printing is? Maybe sort of. So the PolyJet technology has been around for 25 years-ish, somewhere in that range. So over the years, they've perfected that technology and got to a point where, like I said, one of the benefits, full color, flexible material, rigid material, all in one model. So you can do really complicated models of the human anatomy with this technology.
That's
one of the toughest spots of being able to do those models. The printing part is, a challenge. The post-processing is a little bit difficult at times, but one of the biggest bottlenecks that we have in our industry is the front end piece, the segmentation piece, because of how long that it takes and having to have engineers, an army of engineers that are sitting there doing this work. Well, Axial has actually unlocked that with us, with our customers, and what we see out there in the industry, because you're able to do this stuff at scale with their platform, which is really cool and exciting. So I would encourage all of you have a few different types of models up here that you can put your hands on and take a look at. And my situation is such that, again, being able to use the technology for my own case is something that is kind of a blessing for me, that we get to be able to do that and print these models. So I'd love to talk to you guys afterwards if you want to come up and ask me any questions about how we do it. Obviously 15 minutes doesn't give you a lot of time, so I have the video showing in the background of how the parts are actually made. To give you guys an example, some of the cardiovascular models that we make for some of our customers, those models get segmented, like I said, in minutes. Maybe some of the more complicated ones may take a few hours. We're able to print those models overnight, literally, and we'll have a clinician, or they'll go to our customer. Those models will go onto an airplane. Somebody's flying across the country to the East Coast, Canada, around the world for surgery. Like literally, those models are going into the OR. And when I had mentioned that we've, saved life, extended life with this technology, and so that's kind of the gist of it. So I don't know if anybody has any questions, or it's a lot of stuff to unpack in 15 minutes, I know, but I'd love to talk with you guys afterwards.